So, hello, good day, everyone. I am Adiel, an incoming senior in the Philippines. My mentor, Emily Edwards, is a PhD student in University of British Columbia in the Resources, Environment, and Sustainability program. She helped a lot in making this literature review on microplastics entitled Incorporation of Biochar and Hydrophobic Iron Nanoparticles into One Filtration System for the Removal of Microplastics, a review. So presently, there is about 269 million kilos of microplastics in oceans. What makes this concerning is because chemicals or additives are added to plastics to enhance their properties. In addition, they can also absorb chemicals from their surroundings, like heavy metals and organic pollutants. Because of this, aquatic animals are exposed to health risks because not only are they consuming non-consumables, but they are also consuming heavy metals, additives, and organic pollutants. Why I chose this topic is because I noticed how pervasive microplastics are in both Philippine waters and drinking water. So prior to this, I did an experimental research on biochar and hydrophobic iron nanoparticles. I really wanted to enhance this project I did with my friends through combining both methods. So that sort of birthed my motivation for creating this literature review. For biochar focused papers, I use the keywords biochar, microplastics, absorb, and filter. While for magnetic extraction focused papers, I use hydrophobic iron nanoparticles, filter, and microplastics. Lastly, for magnetic biochar focused papers, I use magnetic biochar, filter, and microplastics. So I searched for biochemical engineering journals focused on experimental filtration technologies and their applications using Google Scholar, and further refined the scope to peer-reviewed articles published between 2018 to 2022. So presently, there are many methods to combat microplastics, but for my literature review, I solely focused on biochar and hydrophobic iron nanoparticles. So biochar is a method that uses burnt or pyrolyzed organic material for its porous nature to remove microplastics. This method has a removal rate of about 95%, while iron nanoparticles is a method that uses iron nanoparticles with a hydrophobic coating, allowing magnetic extraction of plastic sediments. This has a removal rate of at least 80%. So by principle, a filter method that incorporates iron nanoparticles and biochar should have a removal rate greater than the two methods, which was the case for magnetic biochar. A filter that modifies biochar with elements possessing ferromagnetic properties. So the type of magnetic biochar we focused on is an iron modified biochar, which is proven to have a removal efficiency of about 100%. So in comparison to the two aforementioned filters, magnetic biochar is superior in terms of its removal efficiency. However, we did observe magnetic biochar to be impacted by certain aspects of the environment, which are interfering ions and dissolved organic matter. Interfering ions can cause a decrease in removal efficiency. But one thing to note is that certain plastics are immune to this because of the complexation of plastic sediments and the selective absorption areas of the biochar particles. For dissolved organic matter, or DOM, the removal efficiency decreases as DOM increases due to the attachment of the DOM particles to the magnetic biochar and plastic particles. This results to lesser chances of plastic extraction. So the main goal of my literature review is to encourage the shift in research focus of studies to conceptualizing solutions for the concerns regarding environmental parameters. Tackling the effects of interfering ions and DOM can enhance the device's sustainability. Another thing I'd like to point out is the enhancement of the magnetic aspect of the filter. So currently there isn't much attention given to the magnetic components for the device, Granted, there's only one study so far. So this paper hopes to encourage future studies to review the enhancement of the magnetic system to prevent the degradation of the filter's removal efficiency. Tackling these two issues could improve the feasibility of the application of magnetic biochar in large-scale environments and situations. My Talaria experience can pretty much be summarized into 2 or 3 words, and that would be intellectually fulfilling and fun. So my mentor has been a huge help in finishing and refining my work. I did have some prior knowledge in microplastics, but this program and my mentor really aided in expanding my knowledge in the field of environmental science and water treatments. Contrary to that, I was really stuck on actually creating the literature review. I had no idea how to write a literature review paper, so starting out the methods and results was very hard. But my mentor really helped along this learning process by giving me sample works and pointers and helping me realize how to approach writing literature reviews. There were some issues that we've encountered in our communication, and that would be because of my unstable connection and electricity. So, case in point is just now where there was a power outage in my area and I had to request to move my schedule. So, but these issues were resolved through communication with my mentor and the core members of the program. So, this program and my mentor were so accommodating and incredibly helpful. And that aspect especially shows in situations like these where communication is hard. So going back to the literature review, the key takeaways are that hydrophobic iron nanoparticles and biochar are cost-effective, sustainable methods, and the incorporation of both filters, i.e., magnetic biochar, is a promising filter that can remove both big microplastics and rogue microscopic plastics. The paper emphasizes the need for investigation on the long-term effects of environmental parameters, and it also hopes to change the trajectory of future works to conceptualizing concepts that can combat the effects of external conditions on the filter and enhance sustainability. Sorry for that. So lastly, these are my references. Thank you so much for listening, and thank you to the program for this learning opportunity.